Hey everyone, how's everyone doing today? Woo. Woo. Nice. Got some enthusiasm going here. We're going to talk about LLMs. So interesting topic, hot topic, and I'm going to talk about how LLMs work behind the scenes. So this is going to be really important for any developer or any AI enthusiast. A little bit about myself. I'm a software developer. I've been in the industry for about 8 years. My name is Umer. Please connect with me on LinkedIn. I've given a few of these talks before. So yeah, please connect. Alright, so what we are going to talk about today is I'm going to do a little bit of LLM 101. So for those of you who have been using ChatGPT and other LLM models, we're going to talk about how behind the scenes these LLMs work. Then I'm going to talk about the 5-step process of LLMs, the large language models, how ChatGPT and other systems work. I'm going to talk about the takeaways around what we discuss, and I'm going to give you a little bit of energy impact. So how much energy does our LLM queries consume? And then in the end, we're going to conclude with some of the takeaways. So here we go. So when we talk about AI, we kind of thinking that it's some really intelligent being that's processing all the information, kind of like iRobot. But really, it's kind of dumb. You don't want to say that word, but it's kind of exactly that. It's kind of dumb. But why we're talking about it is because it has gained a lot of popularity, and the reason why it's gained a lot of popularity is because it does give you a lot of genuine information. Like if you ask ChatGPT about what you're going to be doing in the next 5 years, it's probably going to give you better information than your therapist. So yeah, it's gained a lot of popularity. So this is a chart that shows that how soon have the platforms gained popularity. So how soon have these platforms gotten to the road of to 100 million users? And you can see at the top there, Instagram Threads has reached 100 million users in 2 days. But then right below it is ChatGPT, which has gained 100 million users in about 2 months. So that's why we're talking about it. So the question here, does the model predict the next sentence? So when you ask ChatGPT, hey ChatGPT, what is the meaning of life? Does it actually predict the next sentence? The answer to that, no, it doesn't. So the next question I ask you is, does it predict the next word? Anyone? Does it predict the next word that is going to give you like as an output? Does it predict that or no?
Yes.
There was a yes and no.
Yes.
Does it predict?
Yeah.
Well, it's actually no, it doesn't predict the next word for you. So what it does predict is a token. What's the next token going to be? Does anybody know what a token is? We talk about LLMs. The first thing that comes to mind is tokens. ChatGPT is using a lot of tokens. I'm running out of tokens when I use an LLM. What is a token? It's actually right there. It can be a word. It can be a part of a word. It can be a number, or it can be other than that as well. So it can be a lot of things, but it's smaller than, it can be a word, it can be smaller than a word. So LLMs work in tokens. We're going to talk about how they work in tokens. So here we go. This is a pipeline of how one token is actually predicted by any LLM model out there. So if it's GPT or Llama or any other model, every LLM model uses pretty much the same pipeline to predict the next token that it's going to give you. So what is the process here? Well, the process is this 5-step process. Step number 1 is that it actually creates tokenization. So it basically creates pieces of text. And then the step number 2 is embeddings, which basically means that converting those pieces into different forms of vectors. And then it actually transforms that through a transformer. And that is actually doing context processing, which includes attention. And then it's going to give you probabilities for the next token, which is actually token scores. What are the different sort of possibilities for the next token that it's going to give you as output. Then we have sampling, and it goes in a loop. So we're going to go in a little bit of detail on all these steps. So the first step here is tokenize. So for any LLM model, like I said, a word can be a token or it can be multiple tokens. So for example, for a model like for OpenAI's GPT model, what you can do is you can actually go to their website, tokenize.openai, and you can find out the tokens that they're using. Let's actually try to do that real quick. So you can look up tokenize OpenAI, and it's going to tell you all the tokens that for a word or a sentence that it creates. So for example here, indistinguishable is actually 4 tokens, and the word D is actually 1 token. So what this means for you is that tokens can be like more than words. So basically, like if you have 10,000 words, it can be around roughly like 40,000 tokens. So it's like actually like tokens are more than words. So why does it matter? So I put in this website, you can look at it. It actually tells you how many tokens your query is going to generate. I don't have internet, otherwise I would have shown you. But yeah, so that was the first step. The second step is the embedding. So once you have the token, you actually convert that token into something called token ID. So on this website, the tokenizer, it will basically convert your word into different tokens, and then for each token it will give you something called a token ID. So a token ID is actually a number, and then the second step in LLM processing is called embeddings, which means that we convert those numbers into vectors in space. And those vectors can span through different dimensions as well. So that's the second step that we do, and why we do that is because LLMs actually try to cluster different words together. So for example, for an LLM, king and queen would be one cluster, so they would occupy one space. Then Python and JavaScript would be another cluster to group them together. That's how they distinguish between different sorts of words. They clustered them together. So Python with JavaScript is a different cluster than Python with Reptile and Cobra. That's how they're distinguishing it in the vector space. And the third step, this is kind of like the brainer step, which brings in a lot of brain power, is the transformer step in any LLM model. And this step, in simple terms, it basically takes every token and it looks at every other token in the vocabulary. So for example, if it's giving you the next token, it's going to take the vocabulary that it has. So for example, llama has a vocabulary of 120,000 tokens. So it's going to look at all of that vocabulary and find the best relevant token that comes next. It's going to give every token an attention score. And then it mixes the information accordingly. So to give you a simple diagram of how this works is, for example, you have a sentence here like John wants his bank to deposit. So the transformer looks into the vocabulary, all of the vocabulary that it has, and then tries to figure out what context each word has. So for example, the word his, for a human person, his means John because that's part of the sentence. But because the LLM does not have any context of what him means or his means, it gives, the transformer takes the previous tokens and gives context of John. So in this case, the transformer is basically saying that his is John, and the transformer is attaching the context with each token. So for each word, it's attaching the context so that it knows that what the whole sentence means. So it takes in the input vectors, uses the transformer, processes it, and then it spits out the enriched vectors out of it. So once we have the enriched vectors, we have the step 4, which is the probability. So what we do with those vectors is we give all of those vectors a score, and these scores are called logits. We give every token a logit, and then we convert that logit into probability. We use softmax algorithm to give probabilities to each token, and as a result, what we get is probability around the next possible token. So in this case, for example, we have the sentence, the boy went to the, and there is a list of words that can come in next, and every word has a probability of what it can be. So here you can see playground has the highest probability. So the next step, what we're going to do is assign the next possible word at the end of the sentence. So how do we choose which is the best next token? So now that we have the probability, what do you guys think how we would put in the next word there? Like we have playground, hospital, cafe, park, and school. All of these are different probabilities of words that can come in after this in the sentence. So how do we decide which word gets put in?
By score.
By the score, yeah.
It's random.
Is it right? Okay, that's a
It could be random, depending on temperature.
exactly. So basically, who decides which word to use is actually you. So you get to decide which word gets put in next, and the way that you decide is actually through temperature. So this step is called sampling. The basic sampling process is using this greedy algorithm, which means the highest probable word will go in next. So what this means is, in this case, where we had the boy went to the highest probability is playground, so playground will come in next. But this is very consistent, and this is a little bit boring. So what you can do is, for the same prompt, what is Python, you can adjust the temperature of the LLM model, and based on the temperature, it will give you less probable sentences or more probable sentences. And what this means is that if you set the temperature low, so if you set the temperature to, let's say, 0.2, it will give you more predictable output. So every word that puts in next will be the most predictable word. But if you set the temperature high, then it will give you random words. So it doesn't mean that it was being more creative, it just means it's giving you more random words. Alright, so we have the step 6, which is repeat. So we only generated one token. This step repeats every single time we try to predict the next token. So you can imagine that all of the process that I just showed you from step 1 to step 5, it happens every single time the next token is predicted. So what are the three takeaways that we can take from this? Number one is something that you have heard of is called model hallucinates or model hallucinations. So what hallucinations model is doing is the model is not lying to you. There's no concept of lying for a system or for an LLM model. There's no lying. What it's doing is it's actually trying to give you the most predicted outcome. So what this means is that every time it's very sure about the answer. Always check your sources because it's trying to give you the most predicted outcome. That means it's checking the most sort of probable outcome that it has. So you should always check your sources of information especially when the model is very confident on giving you the answer. The second is the takeaway is the temperature. So like I showed you, the temperature actually decides for you how random or how non-random output you get, but it doesn't mean that if you set the temperature high, it's going to be more creative. There's no concept of creativity for an LLM model. All it's doing is that it's assigning the least probable tokens if you set the temperature high. If you set the temperature really high, it's going to give you like really random tokens which probably will not make sense to you. So for coding tasks, try to keep the temperature of the LLM model as low as possible because you want more predictable outcome. For writing tasks, you can set the temperature a little bit higher. And the third one is the context limits. So when any sort of model or API that you're using, it gives you context limits. It's not that the company is against you or it's going to, it's going after your money. It's more that every time, like I showed you, that it's predicting the next token, it has to go through the list of all of the tokens that you had given before, and that's why it is, there's context limits on the model. So be specific, give low context, and it will give you focused results. So what are the energy implications on this? This is just the last bit. So every token costs energy. In the step-by-step process, you saw that how a token is actually decided. And so for a 500 token answer, it doesn't run on the model once. It actually runs on it 500 times. So if you open up your phones and go to this website I created, it's called whatthetokens.com. It actually tells you the amount of tokens that your query is going to consume. So let's say if you go to the website and put in that what is the meaning of life, it's going to tell you how many tokens it's going to take as input, how many tokens it's going to throw out as output. You select the model, and then it's going to tell you how much energy it's going to consume that query. So yeah, do try it out. That's pretty much it for me. That's my lightning talk. Try to give you as much information as possible. Please connect with me on LinkedIn. Thank you so much.
Thank you very much. Always fascinating, and I still can't get used to that from just JavaScript developers. We turn on into a broader AI community driven by JavaScript. So if you can write anything on JavaScript, so I think we have a time for 2 questions, if there are any.
Yeah, any questions from anyone?
Hi, thanks for the talk. I was curious how the Python in your example was put after tokenization into 2 different clusters.
Yeah, so if you look at the example that I showed you, basically it's putting in Python in 2 different clusters by using these vectors. And so basically whenever you convert the word into a token and then give it a token ID, it actually converts that into a vector, and then that vector is given a space in vector space. So all of the vectors that kind of are similar, they are clustered together in this space. So yeah, there's algorithms behind this, and so that's how it works. Any other question?
Yeah, just some quick questions. So you said that it loops over for every next predicted token. Is that loop the same, like tokenize and then embed and then transform, or what are the steps of each loop?
Every single loop goes through all. So every single time it predicts the next token, it goes through the same 5-step process. So it goes to tokenize, give it a token ID, then embedding, which is convert that token into vectors. Then it goes to transformer, then it goes to probability for the next token, and then sampling. And so every single token. That's why it's a very intensive process, and that's why we have this energy issue and people calling it an AI bubble.
Because it's kind of inefficient though, right? Like tokenizing every single time. Wouldn't you just, is the tokenization step going to change?
It's very efficient because it always gives you the most predicted outcome based on how predicted the outcome you want. And so basically, like this process runs for every single LLM that you use. And it's been running so far, so everybody's amazed by it.